Hello everyone and welcome to our mini-test solving to the 20th lecture mini-test Combinatorics. Here is the mini-test for those of you who did not watch the lecture and just want to test your knowledge. You can pause, screenshot, solve, and if you want to solve, let's get right ahead into it. So a student needs a calculator and 2 notebooks. How many possible options does he have if the store has 2 different calculators and 5 different notebooks left to choose from? For this, I write out all the info I have, so what is available and what do I need. I write the formula. Now, since we need to know how many options, we are counting combinations. So notebooks order doesn't matter. We could use the combinations formula, the binomial coefficient, whatever you want. You can also draw the lines and multiply all the values on them like we did in examples, as long as you do it correctly. I'll use the formula because it's more elegant. Let's break the problem down. The formula would only apply to one item, so either calculators or notebooks. We can't use it for both. So let's use it for notebooks, as there's more choices stemming from them. Our n would be all the notebooks we can choose, so 5, and k would be the ones the student chooses, so 2. K is 2, n minus k is 3, n is 5, and we cancel out the 3 factorial, we simplify the 2 and 4 to get 5 times 2 and 10. We have 10 possible combinations for notebooks. But we also need a calculator. So we would multiply this combination we just solved with combinations of the calculators. But 2 factorial divided by 1 factorial squared is just 2. So we have to multiply the 10 combinations of notebooks with the 2 options for calculators we have. Just like, oh, that's a good example. If we had 10 shirts and 2 hats, it's the same way. Actually, it's not. Maybe it's like shirts and pants. You would have shirts and pants encoded in the notebooks. You would calculate there's 10 possible ways you can have a set, like 10 combinations you can have of them. And you decide to add on a hat. How many possible combinations do you have now? It doubles because you have 2 hats. Here it doubles because we have 2 calculators, so 20. 20 options for our student to choose from. I hope this was clear. I made it slightly harder than I explained in the lecture, unfortunately. Anyway, time to cave into the brain rot. What's 6 factorial times 7 factorial divided by a completely random number of 1792? Now, obviously, you can use the calculator here, or you can prove yourself that you're a smart and capable human being and break 1792 into prime factors, which would be 2 to the power of 8 times 7. Yes, that's correct, I forgot. Now, here we have 7 on top and bottom, so let's cross it out, which gives us, what if you have 7 factorial divided by 7, you can cross the 7s out and you're left with 6 factorial. So we're left with 6 factorial squared divided by 2 to the power of 8. Now, something like this. I will write it all out to see what we can cancel and how we can work with. So I just wrote the same numbers next to each other so it's easier to simplify it. And when I'm canceling, I'll use the same colors and the same direction for those who are cancelled by the same term under. So something like this. We cancel the far right 2's with the far right 2's. We cancel the 2 4's with 4 2's. And we cancel the 2 6's with 2 2's. We're left with 2 3's. So altogether we're left with 4 instances of 3 and 2 instances of 5. So we have 9 times 9 times 5 times 5, which is 45 times 45, which is 2025. A simple multiplication, a simple and elegant exercise. Like, I deserve some appreciation for finding a problem that results into 2025 using factorials. At least give me a like for that, please. Thank you very much. And for our last task, we need to know how many different student councils can be made from 12 students if a council has 3 roles, 1 for each member. Since the order of the students doesn't matter here, we use permutations, so fraction of all student numbers, factorial divided by the students that aren't in the council factorial, to get rid of the orders where the students don't participate. Now we can cross out 4 factorial in both sides and we're left with 7 times 6 times 5, which is 210 possible councils. Thank you so much for tuning in to our short mini-test solving. I hope it went well. And yeah, thank you so much for tuning in, and I'll see you all next time. Bye!